Hi everyone, welcome to lesson 10 of the Advanced Higher Stats course. In this lesson, we'll be looking at the normal distribution. You will find this skill on page 22 of the Advanced Higher course spec, and these are the following learning outcomes. To use the normal distribution are as follows. Observations are made independently, so the variable we're calculating, like let's say the number of rainy days in a month, is independent from the season of the year or anything like that. The sample size should be greater than 20, and the shape of the population should be normally distributed. More on that later. The true normal distribution is here on the left. It's a continuous variable, and it has a bell curve shape, and this is what you need to use the formulas we'll be using for normal distributions. And sometimes you can approximate distributions to be normal. So for example, if you have a binomial distribution or a Poisson distribution, which has a similar trend line, you can change it into a normal distribution, which is called approximating. You can approximate it to a normal distribution, and when you do that, you change it a little bit. But more on that in a different episode. Normal distributions can be skewed as well. So this is our normal distribution. But this is a positive skew, which means that this kind of tail end is stretched. That's how I kind of imagine it. So you have this normal distribution, but this bit is stretched to the right, so it becomes more positive. And if this bit is stretched to the left, it becomes more negative. Let's move on to writing the parameters of a normal distribution. So again, in our data booklet, we will find our parameters in this table, which is always very helpful. And now let's do the questions. If the population follows a normal distribution and has an expected value of 5 and a variance of 4.5, write its parameters. So the mean and expected value are the same. So we can do n5, and we know that v of x is equal to sigma squared. So we can just write 4.5. What if the mean is 7 and sigma is 2? So mean is 7, that's fine. Sigma is 2, so we need to do 2 squared, which is 4. Sometimes you can also write it as n7 2 squared. What if n is 9? The total sum of x values is 41.5 and sigma is 3.5. So here we just calculate the average, which is very simple. Total value of x is equal to 41.5 over 9, which gives us 4.611. And we have sigma, so n is equal to 4.611 sigma squared, which is 12.25. Now let's move on to calculating probabilities using the normal distribution. There are calculators which can do this much faster than we can, and not even for the normal. There are calculators for binomial and for Poisson, but we'll do it the normal handwritten way, and we'll go through all the steps. So the question is, in a university exam, there are 100 marks. The average mark is 66 with a variance of 26. A scholarship summer program can be applied to only by students in the top 5% of their class. Beth got 80 in her exam. Is she able to apply to the program? So first thing we always do is write the parameters of the distribution. So that means n, the average, which is 66, and the variance, which is 26. And that's us already gone a mark in an exam question. What we are trying to find here is if Beth is in the top 5% of her class. And in a normal distribution, what we're looking for is if Beth's score is roughly here. And what this means is that this is the 5% of the cohort, and this is the other 95% of the cohort. But what do these numbers mean at the bottom here? Well, there are a number of standard deviations from the mean. So this is 0 times root 26 away, so this is 0, so the average mark here will be 66. This is 66 plus root 26 because this is 1 standard deviation away, and this is 2 standard deviation away, and so on. One way to figure out the probability is by using a z-value, and z is a measure of how many standard deviation, or sigmas, a particular data point is from the mean. So what we do here is we find a difference between the mark we're looking at, which is 80, that Beth got, and the average mark, which is 66, and we divide it by sigma to see how many standard deviations is that data point away. So that means what we write here is z is equal to x, which is 80, minus the mean, which is 66, over the standard deviation, which is root 26. And that gives us 2.75. Look back at the normal distribution, we can see that 2.75 is around here. And this is definitely in the top 5%. It might even be in the top 1%. And it's very clear that Beth has gotten the summer, well, can apply to the summer program. But how do we show that in an exam? In an exam, we won't have that graph I showed before. We will have page 11 of our data booklet, which is table 3, and is how we use our z values. Again, our z value was 2.75. And what we need to do here is find the probability of somebody getting a mark which was less than 2.75 z. And what that is the same to is the probability of someone getting less than or equal to 80. We include less than or equal to 80 because if probability of x being equal to 80 is 0, and that's the same with continuous uniform distributions as well. So it's kind of negating it. We can use the table to figure this out, and how we do that is we go down the table and we go to here, so 2.7. Now we need to go to 2.75, which is here, and we meet right here. So 0.997. The probability of z being less than or equal to 2.75 is equal to 0.997. So that means that if we draw the graph, this shaded region is 99.7%, and the percentage of the top students Beth is in is 1 minus that, which is 0.3%. So therefore, Beth gets into her summer program. Beth can apply to the summer program. Now have a shot at the following question. A manufacturer claims the life expectancy of a car headlight bulb is normally distributed with mean 10,000 hours and a standard deviation of 250 hours, and a probability that a new bulb lasts at least 10,100 hours. So first, and always, let's write the parameter, which is 10,000, and the variance, which is 250 squared. Now be careful here. We were given the standard deviation in our question, so don't think that is a variance and just put 250 down. It's 250 squared. Now we need to find the probability of the new bulb lasting at least 10,100 hours. So the first thing we do here is we calculate a z value. We have our data point, which is 10,100 hours. We minus it by the average, which is 10,000, and then we divide it by standard deviation, which is 250, and that gives us 0.4. Now what we need to do is we need to find the probability of z being less than or equal to 0.4, which if we look at the table, 0.4 and it's just 0.400, so that is 65.54%. Or in stats, we write it in decimals, so 0.6554. What's an assumption you've made to do this? We assume that all the car headlight bulbs are independent of each other. So we don't assume that maybe they are manufactured in different workshops, and some workshops have an environment that affects the life expectancy of the bulb. Sometimes you can be asked to combine two normal distributions and then do questions with that combined distribution. An example of this can be a chocolate cake has an average mass of 400 grams with 30 grams variance, and the box for the cake has a mass of 50 grams with a variance of 2. Write the parameters of the combined mass of the two, assuming it follows a normal distribution. And we're also assuming that these variables are independent, so a larger chocolate cake does not mean that there will be a larger box. And so how do you write this? And how do you answer this? Well, first you assign a variable to each of the variables. So C, I would write for cake. So the distribution of cake is 400 and then it's 30. You can do B for box, and that is followed by a normal distribution of 50 with a variance of 2. And how you would write the combined version is C plus B, also distribution, and you add the two means, which is 450, and then you add the variance, which is 32. We'll be asked to find the difference between two normal distributions. So an example of this would be, in an exam, students who studied 10 or more hours got an average of 75 marks with a variance of 16. The students who studied less than 10 hours got an average of 50 marks with a variance of 40. Show the parameters of a normal distribution, which shows the difference in the marks between the two students. So again, we assign variables. So X is for people who studied, which is and 75 and 16. And Y is for people who didn't study, which is 50 and 40. Now what we want to do is X minus Y, which gives us N, and then you take away the two means. So 75 minus 50 is 25. And then what you do with the variances, you add them. And that is explained more in the laws of expectation and variance video I covered, but you just add the variances. And and as a result, you will get a normal distribution of 25 being the average difference and 56 being the variance. Let's try this following question, which covers everything we've covered in this video. A candle has an average mass of 100 grams with variance of 20. Its box has an average mass of 20 grams with a variance of 2 grams. You've been given this candle in a box as a gift. What's the probability that its mass is at most 30? The first thing first, we combine the two normal distributions. The candle being 120, and then the box being 20 and 2. So C plus B gives us, it's not equal to sign, it's this sign, which is 120 and 22. Next thing we do is we find the Z value. Z is equal to 130 minus 120 over root 22, and that gives us 2.13. The probability of Z being less than or equal to 2.13 is on the table. We go here, 2.1, we go along a bit, 2.13, we get 0.9834. So the probability 9834. The probability of the box being at most 130 grams is 98% and 98.34%. That is the end of this video. Now you should be able to know all of the learning outcomes and be confident in using the normal distribution.